This is number 2 from the mathematical induction practice quiz. Again, I have n equals 1, the first case set up here. We have -2 equals -1/2 times 4. So that's -2 equals -2. So our n equals 1 case works, our base case. I've also set up the if-then statement. We have, and I put in k plus 1s here for my then statement. Again, I'm just putting in k plus 1s everywhere there were k's. So, on the left side of the equation, we add this term with the k plus 1. On the right side of the equation, we replace these two k's with k plus 1s. And now we're going to get the left side to match the right side. So, just like every other proof that we've done, our first step is going to be to swap in. We know that this piece of our series is equal to this. So we're going to replace it. -1/2 k times k plus 3 minus, and then just bring down this guy here, k plus 1 plus 1. And we're going to try to turn that into the other side of our equation. Now, you need to be careful with your negatives on this problem. That's really the key thing. I'm going to go ahead and multiply the -1/2 k through. Because it doesn't look like I'm going to have anything in common and be able to do any fancy factoring here yet. So I have -1/2 k squared minus -1/2 times 3 is -3/2 k minus, I'm just going to go ahead and combine those like terms in my brackets there, that's k plus 2. And the next step, I'm going to multiply that negative through. So I have minus k minus 2. Again, it's easiest if we make this into a 2/2 here in front of the k, since it's 1k, and then we can combine our middle terms since they are like terms. So I have -1/2 k squared out front, -5/2 k as my middle term, minus 2. Since I know I want a -2 on the outside, or -1/2, I'm sorry, on the outside, let's go ahead and factor that out. If I take out a -1/2, I'm left with k squared plus 5k. And if I divide -2 by -1/2, that gives me positive 4. You could have made that 2 also into a 4/2. If you like that better, so that you can just pull out the -1/2. And now we want to factor what's in our parentheses. The -1/2 stays outside. We need two things that multiply to 4 and add to 5. And if we go back and look at what our goal was, I have this k plus 1 plus 3 here, which is the same as k plus 4. And now both sides of our proof match. We can say that conditions 1 and 2 are satisfied, therefore the statement is true.
Made with Doodlecast Pro.